Let's see how easy it is to put together circuits using the STA kit. I have here in front of me a drawing of a circuit, and we're going to build this one. We'll leave out the ammeter. It's not really necessary. We're going to have a 4-cell series battery, 6 volts. We're going to have a switch. That's what that looks like. We're going to have wire connectors. There's a wire connector. And we're going to have a 470 ohm resistor, which will protect the LED from the 6 volts. 6 volts is too much for an LED. We don't want to blow the LED. Now, these clip together using these clips like this. We pop the clip in there, and if we want this to be joined onto that, we just slide it in like that, put the clip over, and that's so much easier than soldering. So let's now put this together on the table in front of this circuit diagram and see how it goes. I've assembled the circuit now. Here is the battery. It's connected through to the switch. There's the switch, clicked onto a corner unit, clicked onto a straight piece of wire, clicked onto another corner unit, coming around the corner. Here we are at the 470. And I just use the connector there. Now my 470 is connected to this piece of wire, and that piece of wire is connected to the LED. The LED is connected to the corner unit, and that's going through this wire into the negative side of the battery. Now, moment of truth. Let's see if pressing the switch turns on the LED. There we go. Bright and shining, nice and red LED. So my circuit is very simple. That's how it was done. It took me a few seconds, far quicker than I could have done it with any other equipment. If I'd used anything else, I would have had to solder the LED. The LED would have had loose connectors like that. The diode would have been similar with a couple of wires. They would have to go into some kind of onto a board of some sort so that I could solder all the bits together. Look at this, 1, 2, 3, all done, nicely connected. Does it work? Oh yes, it does. Does our circuit resemble the one we have on the paper? Yes, it does, except we don't have an ammeter. I said we weren't going to use one. We have our 4-cell battery going through the switch, the positive side going around this way, so the current, the conventional current, is flowing through there in the direction of the LED, the diode. It only allows electricity one way and not back, and those 2 arrows show that it will give off light and then around and into the negative side of the battery. If I connected this in the opposite direction, it will not work, and we can look at that in a minute. But let's just compare. Have we got this situation over here? Let's go back to the circuit. There we are, positive side of the battery, through the switch, around there, around the corner, through the 470 ohm resistor, and into the LED, and out through to the negative side of the battery. Going back to the LED, you may notice that the arrows depicting the fact that light is being given off are not in the same direction as we have on our drawing. That doesn't matter. Light is being actually given off in all directions from the LED. It's not only going to the left as it shows here or to the right as it showed in my diagram. That's not the important point. 2 arrows coming away from the LED showing light being given off. You may remember that the light-dependent resistor also had 2 arrows, but they went towards the rectangle of the resistor. This comes away, left or right, not important.